So, for your warm-up problem, you needed some knowledge from the past. You needed some knowledge from last class. You needed to bring it all together. So, this is kind of like my own version of a problem that's kind of famous that some of you even said as you were working. This reminds me of that problem. And that problem, which maybe you've seen before, says something like you're given two options, $1,000 or a penny today, 2 pennies tomorrow, 4 pennies the next day. So it doubles every day. Whatever you start with a penny, doubles every day, and you get that for 30 days, right? Has anybody heard of that problem before? Yeah. And of course, if you don't know your math, you'd be like, well, if you're starting with a penny, it can't get very far. So I'll just take the $1,000. But that person doesn't know the power of what? Exponential growth, multiplying, right? But this is not as clear because it's not doubling, which would be multiplying by 2. It's just growing by 30%. But it's a similar thing where you look at it and you're like, I have a feeling based on my knowledge of the power of this stuff, but I need to do the math to figure it out, okay? So the situation is you have a rich uncle who wants to help you start a savings account. He's a very nice guy. He's willing to help you out. But he's also kind of annoying. And he wants to teach you life lessons, right? He wants to make sure you know your math and you know how to make good decisions. So he wants you to learn about exponential growth. And in order to do that, he offers you these two options to get started with your saving. And you have to be sure you're choosing the right one because otherwise you could be leaving some money on the table, right? So the first option, he says, is, hey, I'll give you $500 every day. Like I said, he's rich. He doesn't care. $500 every day for a month. Assume 30-day month, right? The second option, he says, is I'll give you $25 the first day of the month, and I'll give you 30% more every day. So the second day, I'll give you 30% more than that. The next day, I'll give you 30% more than that, and so on and so forth, right? And you say, okay, well, I kind of have a feeling based on the way things grow that one of these options might be better, but I got to prove it to myself, right? So I'm going to find the exact numbers to find out which one will be better, all right? So you start out with this option, and you say, okay, well, if I get $500 every day for a month, assuming 30 days, that's $500 one day, that's $500 the next day, $500 the next day. It doesn't really change. So what kind of math can I do here? 500 times 30 because it's what type of growth is this? It's linear, right? So it's just 500 30 times. So 500 times 30, and what does that give you in the end? $15,000. Pretty nice. Sounds like a good deal. I'd take it. Unless there were other options on the table, which might be even better deals, right? Which brings us to this option. Okay, so you got option 2, right? He'll give you $25 a day, and then he'll give you 30% more every day. Okay, so this is growth by a percentage, right? And we talked about the formula for that, right? The formula is y equals a times b to the x, and then b, when we're dealing with percentages, equals what? 1 plus or minus r, but in this case, it's plus because it's increasing. So we'll just go 1 plus r. Well, we need to know our r, and then we'll find our b, and then we'll plug that in, okay? So what is our r?
0.3.
Yep, so we move the decimal 2 spots, right? And we get 0.3 for our r. So that means our b is 1 plus 0.3, and that means our b is 1.3. All right, so let's start filling in this equation. Y equals, A is what? That's our starting value, so that's 25. And then I multiply that by my b, which I said was 1.3. And then I raise that to the x. The x here is what? 30 days, right? So 25 times 1.3 to the 30. Our calculator helps us with that, and we get $65,499.80, and I bet you, or 89 cents was it? 89 cents. I bet you our uncle is not going to give us cents. He'll probably round up. He'll probably give us $65,000 and $500. Beautiful. So which is the better deal?
The second option.
The second option. Now our uncle gets a little carried away. He's a millionaire. He's like, I can give you more than that. So he says, how about 60 days? I won't even check the math. I'll give you 60 days of this deal. How much did you get then? Go ahead. Double it. Okay, let's see. Well, we made 65,000 in the first. We must make another 65,000.
171,609,429.
Oh, your uncle messed up because he's now owes you 100 and how much?
171
$171 million.
million.
Yeah, 172, and I'm sure he's not going to want to, but he's rounded up because he said he'd give it to me. Anyway, so $172 million. So what happened there? We started with $25, and then the first month it went to 65,000 something, and then another month went by, and now we're at $173 million. So what's going on? Why did it grow so much in the second month?
Because 30% of each number is growing larger and larger.
Exactly. So what do you think would happen in the second month of the first deal? In this deal, if this went to 60 days, how many you would make? Just another $15,000, right? So if you're making an investment with a bank, what type of thing should you be looking for?
The type of one where it's an increase.
Where you're getting a percentage increase, right? You ever heard the term or the phrase, it takes money to make money? No? Well, yeah, okay, some people have. What do you think that means?
You have to have money so you can build interest on that money, and that interest grows exponentially.
The more money you have, the easier it is to make more money, right? It's the reason rich people get richer. Because when they go to the bank and they get 10% on an investment, well, they're starting with $1 million. 10% of $1 million is a lot more than 10% of $100 or $1,000, right? So the more money you make, the more money you can make, right? It's its own exponential growth, right? Now, that doesn't mean that you can't make a lot of money from a little bit of money, right? We started with 25, we got to 65,000 in a month. Now, that's also why if you go to a bank, they're typically not going to give you 30%, right? It will probably be less than 10%. Yeah. Like, if you can find 10%, jump on that offer, because that's pretty good.
That's a
Yeah.
good deal.
That's a pretty great rate. Like, if you get a savings account, 3% maybe. Literally, you can take your money out anytime you want. Typically, you'll make more money if you give them the money and you say, I can't touch it for 5 years or 10 years. Like, I can't actually, I won't touch it. Like, I'm literally not allowed. It's your money for 10 years. And then at the end, you give me back 10% more than I gave you, right? But if I want to be able to take in and out whenever I want, I'm going to get a very small percentage, right? Or you can play a market where, like stock market, where it's like maybe I'll make a negative % if it goes down. Maybe I'll make 30% if it goes way up, right? You're just playing, you're trying to make predictions on what might go up, what might go down. There's no guarantees there. But if you want a guaranteed percentage from a bank, the more percentage you want, the more time they get to have your money, right?
And you're not allowed to touch it.
And you're not allowed to touch it.
Okay.
Yep. Yep. So, anyway, power of exponential growth, right? Very powerful, but also because it's so powerful, very protected, right? You're not going to just get it whenever you want it, right? Okay. All right, so there's your warm-up. First is we're going to do a quick recap to start. You're going to do a problem because you have all the tools for it. Problem 2, I'm going to jump back in because it's going to be a little different. And then 3 and 4 you'll do, and then you'll do your homework. Like, this will be a lot on you, right? And a little bit less on me, okay? So, let's start with a kind of a recap of where we're at, though, okay? Because we got to be solid on some pieces here. Now, just to let you know, typically, what we've done so far is we set up equations, right? And somewhere in the word problem, you get your A, and you figure out your B, and then you figure out your X, you throw it all into your calculator, and it gives you your Y, and that's your answer, because you're trying to find your Y. But what if you're given your Y, you're given your B, you're given your X, but you don't know your A? And you got to solve for that. And that's where we're going today, okay? So, first, let's make sure we understand all the pieces. What is the Y? What is the Y in all these problems? The answer, or the, like if it's like a population and it's growing by da-da-da-da, it's the final total, right? It's your final amount, right? It's your n value. Right? And if your Y is your end, your A is your
Initial.
it's your star, right? It's your initial value. And how do you get from your initial value to your end value? Well, something must happen to it. And what is that thing? What do we do to that start value? We
Put it through a percentage.
Well, sometimes it's a percentage, but what if I just told you to double it or triple it? What do I do to find the value? What operation? I have A and I do what to it? I multiply. It's my multiplier. Now, yes, sometimes sometimes your multiplier or your B equals 1 plus or minus R, where R equals your percent increase or decrease, right? Yes, for sure, that happens. But sometimes you're just given your multiplier. Sometimes it says this grows by tripling every year. Like you don't need to worry about percents. You just multiply by 3. Okay? And then lastly, we have our X, which is what usually? Yeah, it's our time or our number of times. Right? The number of times you multiply. Okay? So real quick, let's do a couple more of these where we figure out B values. Okay, so what's the B value when there's a 47% increase? Well, first of all, what's your R? If you have a 47% increase, your R is 0.47. And if you're increasing, your B is 1 plus R. So that is 1 plus 0.47 equals 1.47. So that's your B. And like we said, that's kind of when it goes up. It's pretty nice. Yeah, question? Yeah. Like we said, when it's 1.47 or increasing, you can see the 47 right in there. It's kind of easier to see. But the other way, it's not like necessarily difficult, but it's just not as straightforward because it's not right in the number, right? Here, if we have a 47% decrease, well, now we're doing 1 minus r, which would be 1 minus 0.47 or 0.53. So then you have to do a little bit of mental math there where you're like, well, if I'm multiplying by 0.53, I'm going down 47%. Okay? All right. So now I want you to do application 1 if you haven't started it yet. And this is typical of what we've done already, right? You're plugging in all the pieces, you're putting in your calculator, you're finding your answer, right? When you get to application 2, it'll be a little different, and that's when I'll pop back in, okay? Okay, so for this first one, all right. So first of all, this right here, where this box thing, like you're going to get a question like this on a test or quiz. I'm not going to give you these boxes, right? But you probably want to do a similar deal on your own. You might write like Y, A, B, T, and then figure out which one you're missing. Because it's not always going to be the same thing. Sometimes you'll be missing one, sometimes you'll be missing another, etc. You kind of need to know what you're missing so you know what to solve for. Okay? All right, so you deposit $4,000 in savings. You earn an annual interest rate of 4.5%. What will be your balance if you let the account sit for 8 years? Assuming you don't add or subtract, you just leave it the way it is. Okay? So first of all, is this growth or decay?
This is growth.
It's growth because it's going up. If we're dealing with growth, we know our B will equal 1 plus R. What is our R value?
0.045.
Yep, 0.045. Move the decimal 2 spots, right? 1, 2. So that means our B equals 1 plus 0.045, or our B is 1.045. Okay? Now we plug in what we know. Okay? Do we know the end value?
No.
No, that's our unknown, right? We don't know that. Do we know our start value? $4,000, right? Our B we just found was 1.045. And then the time? 8. Yep. Okay, so now we write our equation. We say y, we leave the y because we don't know the y, right? Equals 4,000, our A value, times 1.045 to the 8th. And we put that into our calculator, and we press enter. Pretty straightforward, right? Press enter, and we get what?
5,688.
And 40 cents. Right? If you're in dollars, go to your cents. Okay, so that's what we've been doing. You basically have everything on this side of the equation. You press enter, you're done. Now, it's not always going to be the case. That's not always what's missing, right? So we move on to the next one. And here, a biologist is studying a new antibacterial spray. It kills 15% of bacteria each hour. After 6 hours of studying bacteria that have been sprayed, he finds 450 bacteria, and it asks what was the starting population. Okay, so first of all, is this growth or decay?
This is decay.
Decay, because they're going down, you're killing them, right? And that means we're going to deal with B equals 1 minus R. What is R? RR. What is RR? 0.15. So our B is 1 minus 0.15 or 0.85. All right, now it says plug in what you know. Okay, so N value.
450.
What was the question being asked here?
It was, what's the starting population?
Good. So we know our N value. It's 450. So that's what's different here. We're not going to calculate the N value. They gave us the N value. We don't know our starting value. So that's our question. Okay. Our B we just found, it's 0.85. And the time? 6 hours, right? All right, so we set up our equation. We say, okay, well, y equals ab to the x. Well, we know our y. It's 450. We don't know our a, so we just write a. And then our b is 0.85 to the 6. Now, you have some options here, but I have a recommendation. You could find out what 0.85 to the 6 is right now. And you could calculate it and then multiply that by a and then divide both sides by that. But if you do that, you're going to round. There's no way around it, around the rounding. Okay? Your other option is, you can think to yourself, what's multiplying by a right now?
0.85.
0.85 to the 6. So what's the opposite of that? Divide by 0.85 to the 6. And then divide this by 0.85 to the 6.
Wait, but then you would do it, once you would divide it, you would have the exponent thing.
You sure would. So you end up with a equals 450 divided by 0.85 to the 6. So you can put that right in your calculator. How do you put that in your calculator? Like this. You would do 450 divided by parentheses 0.85 caret 6 parentheses enter.
Oh.
And you will get your exact number. Because we're talking about population of bacteria here, right? And what is the answer if you do that? What do you get?
You get 1,193 bacteria.
Bacteria, right? And we wouldn't do a decimal because you can't have a piece of a bacteria,
No.
right? Now,
Once it dead,
did anybody figure out 0.85 to the 6 and then divide? Yes? Don't be shy.
I have done that. I rounded it to
Okay.
0.
And did you get 1193 when you did that?
What?
When you did 0.85 to the 6, found out what that was, and then divided both sides by that, did you get exactly 1193?
No.
No, right?
Five.
And don't we want to be as accurate as possible,
You got
right?
I got 5,600.
All right, well, something else happened there then.
Oh, wait, no.
You probably got like 118 something.
Yeah, I got 1184.
Right, which is close, but it's not the actual answer, right? We need the actual exact answer here. Think of it as this is a scientific experiment. They need to know exactly how many bacteria would be left, right? We need to be precise. We need to be accurate. So we don't round in the middle of the problem. We divide by the exact number and get the exact answer, okay?
I did it a different way, but I got a different number.
Well, that's the answer. What did you do?
I did 450 times 1.15.
Well, that's going up by 15%. This was going down.
But we're going up like from 450.
No.
Nope. 450 was our end value, and we started at a higher value than that. That's not the same as going up by 15%. That's not how you want to think about it. You want to think about, I have my end value, what was my start value? Not increasing that by 15% to get back to your start. That's not what you want to do.
But it works, right? It should work, but not.
No, because 15% of this is not the same as 15% of your start value. It's different. Yeah. So it won't actually get you back where you need to go. All right, so now you've seen a different type of problem where you're not just looking for y. So there's 2 more problems. Go ahead and work through those 2 problems. When you finish them, you come show them to me. If they look correct, I give you your homework, and you got about 20 minutes to work on your homework. All right? All right, so on your homework, it was basically practicing using percentages to grow and to decay. Today we're going to be doing a little bit more with applications in terms of okay, well, what if multiple years go by, and what if you don't know certain pieces, not just the end value, right? But yesterday was more, or last class was more about like, let's set this thing up, let's see what happens when you grow one time, that kind of thing. Okay, so we'll start with the front side. Were there any questions on any of the problems on the front? Okay, if there wasn't, but if there was. So the only one that I got really a couple questions on today was if you have a handbag that's on sale and then taxed, you need to find out the sale price and then add the tax to that. So for instance, this bag was $25 and 30% off, right? So, well, you're going to multiply by 0.7. Two ways to figure that out. 1 minus r, 1 minus 0.3. Or you can think to yourself, if I have a bag and it's going to be 30% off, how much percent will be left? 70%. So I want to know what is 70% of the original price. That's why the math is what it is, right? So you multiply by 0.7. That'll tell you what 70% is, right? What 30% off is. Then you take that and you say, well, I need to know what tax would be on that. So that's 100% of that plus whatever the tax rate is. In this case, it was 9.2. So you would say, okay, I got my new price. I'll multiply that by 1.092. That'll give me 109.2% of that price. And now I know how much I pay. Okay, so that's your thought process there. All right, on to the back. I've gotten a decent amount of questions today on this box here.
I just copied from last.
All right, so let's talk about this box. Actually, I'll go to the blank for this one. This box. Okay, so the first three of these were kind of different than the second two, or the last two, I should say. The first three were saying, okay, you're either going to have an increase or a decrease. You can't have both, right? You'll have one of them, and then you tell me your R, you tell me your B. Now, remember, your B equals 1 plus or minus R. What is your B? Your B is your multiplier. It's what you multiply by. Your R is your percentage, right? You can't just multiply by the percentage. For instance, if you're going up by 30%, I can't multiply by 0.3. That's not going to go up by 30%. That would give me a much smaller amount than what I started with. 0.3, that would be less. I need to multiply by 1.3, 1 plus 0.3. Or if I'm going down, I need to multiply by 1 minus 0.3, right? So your percentage and your multiplier are not the same thing, right? So this box was kind of like differentiating the two. If you have one, can you find the other? If you have the other, can you find the one, right? So at first, it's like, all right, I have an increase of 17%. What is that as a decimal? What is that as an R? 0.17. Because I'm increasing, my B would be 1 plus 0.17 or 1.17, right?
Yeah, I did that. I just didn't do the step-by-step part.
It's okay.
1 plus 0.
That's okay, as long as you were able to get your R, get your B. Now, this is kind of, like when it increases, it's kind of easier to see because you're like, yeah, I'm going up by 17%. I see the 17 right in the number. That's easy, 1.17. What's tricky about decrease is you don't see your percent in the final number unless you can do it in your head. For instance, if you're decreasing by 34%, right? You're going down 34%. What's the R? What's the percent as a decimal? 0.34, and now we're doing 1 minus, so I go 1 minus 0.34, so my multiplier is 0.66. So you'll see okay, I'm going to multiply by 0.66 to go down by 34%. So it's not quite in the number. You can kind of mental math see it in the number, but it's not like this where you can see the 17 right there. This is, well, you have to do a little bit of well, if I'm going down 34%, I want to have 66% left, so I'm going to multiply by 0.66. That's the thought process. This is the formula, okay? Now, moving along, what about these problems? Well, here you have your B, you have your multiplier. and we want to know the percent. So there's two ways to do this, right? There's the thought process way, there's the formula way. If I have $100 and I multiply by 0.81, how many dollars will I have?
181. Oh, wait, I mean
81.
$81. So did I go down or up? Down. How much did I go down?
19.
So I went down what percent? 19%, right? So you can always think of it that way. If I had $100, what would happen, right? So this is a decrease of 19%, meaning our R is 0.19, right? And you can back into it that way.
I did the formula.
So for the formula, what did you do?
I put it like the cost is B is equal to
1 minus R, and what's RB this time?
RB is 0.81, and then I just solve for R.
Yeah, exactly. So if you know that 0.1 equals 1 minus R, that's an equation. You can solve for R, right? You can get R by itself, right? And if you did that, you could either subtract 1 from both sides and then divide by -1, or add R to both sides and then subtract to get it by itself. Either way, you would get R equals 0.19. That's your percentage that you went down. Make sense? Now this one, you might be able to do without having to do any of that because you see, oh, 1.54, I must be going by 54%, right? So that's an increase of 54%. Okay, does those boxes make more sense now? Good. All right, now in this section, you kind of had to do it without the box. You had to look at this and say, well, if I'm multiplying by 0.94, how much should I go down? 6%. If I'm multiplying by 0.67, how much should I go down? 33%, right? If I multiply by 1.3, did I go up or down? Up by 30%. Tricky one. If I'm multiplying by 3, I went up 200%. It's 1 plus R. If B equals 1 plus R, and B is 3 equals 1 plus R, subtract 1 from both sides, your R is 2, 200%. Question?
The 1.3 up how much?
How much did it go up?
Yeah, you said
30%. Your B, it's higher than 1, right?
yeah.
So it's 1 plus R, right? And your B is what?
1.3.
So 1.3 equals 1 plus R. Now get R by itself. Minus 1 minus 1. R equals, what is 1.3 minus 1? 0.3. If you change that to a percentage, would be 30%. Okay? And then for each of these, you just had to plug in your X or T and find your value. Now, last two problems, you were asked to come up with a word problem. Some people just, in my class, would say, yeah, I didn't do that one. It's like, I decided I get to skip that one. First of all, you don't get to decide, you get to skip part of your homework.
Are we going to have it on test?
You might, but also don't skip these because they're good. They're like, these are like the best problems for you. So when we're learning to teach, right? When we're teaching, okay, how do you make sure students really understand it? Like what comes up all the time is make them make their own problems. Because if they can make their own math problem, the level of understanding of the concept to be able to create your own problem is the highest level, right? If you can do that, you really get it, right? So when you get a problem like this, challenge yourself to do it. Because if you can do it, you really get this thing. Because you kind of have to see it from all sides to do it, right? So if you were able to do these, you can feel really good about your level of understanding, okay? So make sure you try these, like challenge yourself. All right, so if you're doing one of these, right? Well, what do you need to do? You got to think about it. You got to use your imagination a little bit. But first, you got to know your pieces, right? We know that this is y equals ab to the x. And our a, in this case, would be 50. Our b would be 0.85. Well, we just talked about what that means. This thing is going up or down? Down by what percent? 15%, right? So then all you have to do is make a problem where you would start with 50 and you would go down by 15%, and it's to the t, so really over time it would continue to go down by 15%. So something like that. So that's where you would go with it. Anybody come up with something? Yeah.
The $50 bag is marked down 15% each day. It's on sale. How much does it cost on the fourth day?
I like it, right? Because it's realistic. You could see something for $50 being down 15%. Maybe it's on clearance and they just need to keep knocking it down, right? So the days go by, it gets cheaper and cheaper. Yeah. Anybody have another one? I see a hand half up. Hannah, did you come up with one?
Sneakers costed $50 when you bought them. For each time you walk a mile, their value decreases 15%.
I like that too. Depreciation is what that's called. So, for instance, I used to be an accountant before I was a teacher, and we would buy new computers, right? And that was part of the value of our company is our infrastructure so I would have to report how much are our computers worth, right? Because that's value. Like you could, I guess, technically resell them and get cash back for them, right? So say you buy a computer for $1,000. Well, 5 years from now, it's not worth $1,000. There's been newer computers that come out. They are better. It's not like you could resell it for $1,000. So you do a little bit of an estimate. You're like, well, how much percentage would it really be worth? Well, let's make a decision and say it goes down by 15% a year or 10% a year, something like that. And then you have to, every year in your accounting, figure out the new value that it's worth. And you have to make predictions for your management. They will ask you, hey, in 5 years, how much will all of our computers be worth? Like, well, we have 10 computers. They're $1,000 each. Each one will go down by 15% a year, yada, 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 and then you give them a value, right? But that's exponential decay. That's depreciation. That's a real thing that happens all the time. So yeah, cool. Cars are a big example of that. Your car will always go down by a certain percent. You can't unless you have a Ford Mustang 1957, and suddenly it goes back up because it's like a collector's.
You would not believe how many old Ford Mustangs are on eBay for $2,000.
Well, I bet you they're not in great shape. In tip-top shape. All right, so there you go. Any other questions on the homework? All right, so we're going to dive into the lesson now. Now, for the lesson, the way it's going to work